Hello everyone, this is Algebra 1 for Faith. Today's date is May 12th, and we are going over 11.5, which is adding and subtracting radicals. And before we get into that, let's go to the Lord in prayer. Heavenly Father, we just want to praise you and thank you for giving us this day, each day you give us. Father, we pray that you'll grant us the wisdom of heaven, not just on us, but also on all the authorities in our world. And Father, we also want to give you honor, praise, and glory for sacrificing your Son for us when we were yet still sinners. We love you. In Jesus' name, amen. All right, guys, so adding and subtracting radicals is actually something similar to what you have done with polynomials. And to clarify that fact, let's go ahead and look at just our lesson opener, which is just going over some things that you've done in the past. I'm going to hide my words right there before we get to it. So let's look at this lesson opener. I have 5x plus 3 negative x plus 6. So what we did when we were putting together these terms is we had this little byword that we would say that we can only put together like terms. So the only things I can put together are the x's. And so I've got a 5x plus a negative x, which would end up being a 4x. Then I have a 3 and a 6. So those are like terms. Those are constants or numbers. So that would become plus 9. I need to kind of watch myself because sometimes I've been going crazy with the stuff. Hey, that was right. So I'm actually doing a little bit better with mental math today. All right, going on to number 2. I have 8a minus 7b minus 3a plus 7b. The only things I can put together are the a's and the b's. So let's look at what happens if I put the a's together. 8a plus a negative 3a would become a 5a. Look what happens with the b's. I have a negative b adding a positive 7, or negative 7b adding a positive 7b, which means they would just subtract, cancel out each other, become 0. So for this one, all I've got is 5a. It's not standing out there, so I'm going to circle our answers. Going to the next one, we have 4x squared plus x plus 2 plus 6x plus a negative 4. This is kind of starting to look up like our trinomials that we used a lot in the last chapter. So 4x squared, do I have another x squared I could put with it? Nope. So I'm just going to bring down 4x squared. X, do I have another x term that I can put with it? Yes, the 6x. So I'm going to add x to 6x, and that's going to become a 7x. And I have a 2 plus a negative 4. So 2 plus a negative 4 is going to become a negative 2. So there's my answer for that one. What did I do in order to simplify all of these binomials, polynomials, trinomials, however you want to call them? We combine like terms. So that's our, I don't want to say mantra, that's our goal for math terms when we're trying to put together stuff, is combine like terms. Well, you have to keep that same philosophy when we go into radicals. So I'm moving down the board. When I am adding and subtracting radicals, I'm going to have to combine like radicals. Whoa, way too close. And when I say like radicals, what does that mean? That means my index number has to be the same, and my radicand, or the number underneath the radical sign, has to be the same. Those two things have to take place in order for me to be able to add and subtract those radicals. Is basically these numbers, this number has to be the same. And what I am going to tell you is, in order to add and subtract the radicals we're doing today, you probably are going to have to flip back to 11.2 where we were simplifying radicals, because that's what we're doing a lot today as well. Is 11.3, 11.4, we multiplied and divided radicals. 11.2 is where we simplified radicals, which I noticed not a lot of people have watched. So I'm not sure if I didn't put that on Facebook. I'll check that later. So you might have to go to 11.2. Remember, on today's lesson, as well as every lesson in Chapter 11, I'm going over quiz questions. So you might want to, tell people that, since this is your last hurrah in algebra, or these quizzes you're doing this week. And we've got several of them. So let's start. I've just chose a few from your homework that we're going to do. You may use all of the examples if you wish. I'm going to tell you, I have a jaw popping, so if you hear like this crunchy, grindy sound, it's my jaw. I don't know what's happened. My husband would say that I've probably talked too much. All right, let's go to 17. If I was doing homework, if you were here, the homework we would do is basically 11. It says to do 1 through 11 odd, do all through 13 through 16, and then do 17 through 35 odd. Well, I'm changing that. If you're going to practice, do 1 through 11 odd. I would totally ignore that table. The reason why they were having you do that table is they wanted to really clearly indicate to you why you could not cram x and y underneath a radical sign and it be the same thing as radical of x plus the radical of y. And I think that's a totally confusing exercise. So totally ignore 13, 14, 15, and 16. I'm kind of ignoring everything and I think some good practice for your quiz before you get into it, or some good practice just to understand this, is just to maybe concentrate on 17 through 27, doing the odd ones. I'm doing 17 and another one. I think, what number was it? 21. We're doing 17 and 21, just so you've got an indicator of having two different radicals or two different index numbers for radicals to make sure you understand what you're doing. So I have the radical of 5 plus the radical of 20, minus the radical of 72. Well, radical 5, that's a prime number, cannot break it down anymore. Then I have these two other numbers. And remember, what I'm trying to do when I'm simplifying radicals, and since I don't have an index number, that's indicating that it's squared, that's two numbers multiplied together to each other. I'm going to try to break these down. Yes, I could break it down to primes, that's fine, and then pick out the two prime numbers, but it might be easier just to break it down into factors that might have a perfect square. So I'm going to let's just work on 20, and then we'll work on 72. So 20, what are two numbers that would come up to 20 that I would factor together, multiply together, that would become 20, that might have a perfect square in it? And you might pick this out, you might not, but those common factors of 20 would be 4 times 5. And then I would take the perfect square out of 2, or out of 4, which would be the 2. And then now I have this radical that looks similar that I could probably add to this one up here. Now let's look at 72. Now 72, I feel like most people are just going to say 8 and 9. And that's perfectly fine. In my book, they give like 36 times 2 because that's just an easier step. But I really think most of you are going to say, all right, this one is going to be 8 and 9. And you would probably go ahead and say, oh, okay, 9 is a perfect square, so I'm going to pull that out. And then you would leave 8. But 8's not a prime number at all. 8's not prime. There's actually another perfect square hiding there with 8. So what are some factors of 8? How about 4 times 2? There's another square there, right? So I need to go ahead and pull the 2 out of there. So that's going to end up being 3 times 2. Now I have this radical of that prime number of 2. And this would become 6 to the radical of 2. And we have all these things added together. So let me bring down everything we've done after we simplified it. I have the radical of 5 plus the radical of 2 to the radical of 5 plus 6 to the radical of 2. Well, what? Can I combine any? Remember, if I'm combining them, they have to have like radicals. So do you see a like radical? How about the radical of 5? And that is true. I'm going to go ahead and put the radical of 5 and add it to the radical of 2 to the radical of 5. So that would become 3 to the radical of 5. And, oh, that was supposed to be negative. I just noticed that. See, it's negative here. So it should be negative, negative. And then the radical of, or 6 to the radical of 2, I have nothing to combine that to. So I'm just going to leave it. It's just going to stay just like that. So your answer for 17 is 3 to the radical of 5 minus 6 to the radical of 2. Let's go over here where we have some that are cubed, or cubed if you're from Cuba. Cuba, I guess. All right. So remember, when we're looking with the index number of 3, and if things are being cubed, then I'm looking for these numbers that are being multiplied 3 times. And I erased our perfect cubes and I erased our perfect squares, hoping maybe they got in your head. If you're completely confused, go to a previous lesson, yesterday's lesson, where I went over them. And all of these have one of those perfect cubes in there that we've been going over that we can very quickly factor these down. So let's look at 21. Well, 16 is probably the easiest one, because if I just break that down into the common, some very common factors, that would be 8 times 2. I'm going to leave that there. So this is a cube, a perfect cube. That would be 2. I could bring a 2 out of there, and now I have 2 to the radical cube of 2, right? Yeah. There we go. Now, there's actually in here, you would think 81 perfect square, 9. No, this is cubed. There is something being cubed in there. It's just, it's hiding there. So think about 3. Try to divide out 81 by 3 because you can add them together using your divisibility rules, and 81 is divisible by 3. So, and then you're going to find your perfect cube. So your perfect cube there would be 27 times 3. What? This is a cube, perfect cube. So I'm going to bring 3 out of that. Because remember, 3 times 3 times 3 is 27. So it's 3 to the radical of 3. What about this one? There's a perfect cube in there too that we have gone over for the past few days. That perfect cube would be the 125. This is 125 doubled. So what would that be? It would be 125 times 2. So 2 is going to stay underneath. This is a perfect cube. And 125, that's perfect. That's the perfect cube of, just in case you've forgotten, is going to be 5. So 5 times 5 times 5 is 125. Left under the radical is going to be 2. Now remember, I can combine like radicals. Like radicals means it has to have the same index number and the same radicand, or that same number that's under the radical sign. They just call it a radicand. So, do you see same radical? Yeah, right? So I'm going to go ahead and combine the radical of 2, or cubed 2, whatever, these two together. So that's going to become 7 to the cubed radical. I don't know what you'd call that. And then I would leave my 3 left off. There we go. That's the most I can combine it. I can't do anything else here. Never, never, never try to use 2, all right, if I had the radical of x, and then I had the radical of y. If I wanted to multiply those together, I could. That's what that whole table is saying. I can never do this, guys. I can never put those 2 under there and add them together. There's actually a time that you could, but it would be if both of those, you knew what the value of them was, and both of them were 0. Then you could. You can't, but see, that's not going to work. So never try to do that. You have to factor it and make sure these radicals, simplify it with factoring. Make sure your radicals are the same before you combine them. Now, we have 2 quiz questions that we're going to work on. And it's your quiz that's over 11.5 and 11.6. So we have a similar quiz question. Let me look at this one. I have the 2 to the radical of 3. And then I am subtracting 5 to the radical of 12. And finally, I have 8 to the radical of 75. All right, very clearly, this one is a prime number, so it's factored or it's simplified to its simplest form. These two aren't. In both of those numbers, you have a square, a perfect square, that's hiding there wanting to come out. And rather, you could factor it down to complete primes if you wanted to. That's perfectly acceptable. But it's probably easiest just to say, what are some factors of 12 that might have a perfect cube there? Well, for this one, that perfect cube is going to be, perfect square is going to be 4. So 4 times 3. I'm going to go ahead and bring the 2, because 4 is a perfect square. It's 2 times 2. I'm bringing the 2 out, and then I'm going to multiply that 2 to this 5 that's hanging out here. So this radical expression is going to become 10 to the radical of 3. What about this one? Well, let's think about that one. 75, and some of you might get that, especially if you got quarters with you. I know that 75 cents is basically 3 quarters. So what are 3 quarters? Oh, 25 cents. So I can break this one down pretty easy. My perfect square is 25, but 75 times 3. Got to have both of those factors in there. So what do I have here? I'll break that. I'm going to bring out the 5. That's a perfect square. Bring out that 5. Multiply it to the 8. And now I'm going to have, that's going to become 40 to the radical of 3. Then I'm going to go ahead and just bring down this expression that I've not used at all. So 2 to the radical of 3. Lo and behold, what do I have? All of my radicals are now the same, which means I can combine all of these numbers. My radical is going to stay the same, but I can combine the 2 to the 10 to the 40. So let's do that step by step. If I add 2 to a negative 10, that signs aren't the same. Going to subtract, take the sign of the larger number, that becomes a negative 8. Then I'm going to add that negative 8 to 40. Signs aren't the same. Going to subtract, keep the sign of the larger absolute value number. So subtract the 10, this would be, these two combine to be a negative 8. If I subtract that negative 8 from the 40, that's going to become 32. And that's my answer. 32 to the radical of 3 is the answer for my quiz question. You have one more quiz question that comes from 11.5. On your quiz, it's 11.5 and 11.6. We'll roll down here to some blankness. Actually, I'm going to get rid of this one because it's still showing. There. So let's look at my next quiz question we've got that's kind of from this section. So I have 12a. This is just adding some variables to it. To the radical, and this is being squared, to 3a cubed. So yes, we've got some simplification that we're going to have to do through here, which is going to require us to factor some things down, but we're just going to take it step by step with each term. And then if I've got any like radicals at the end, we'll combine those. Remember, like radicals indicates the index number and the number or the radicand that's underneath. 27a. And then my final one, 7a squared and 18a cubed. All right, can you see all of that on the board? Scooter down just a little, just to see. So, for each one of these, I'm going to break it down a little bit. So technically with the 3a, there's not a whole lot going on with this 3a cubed, except inside this 3a cubed is a 3a squared, okay? So basically, I need to take the 2 away and then bring one of them out here and multiply it to this. But remember, exponents, if they're being multiplied, are added. So that one, and the other thing that you could do, the other way we talked about this, that you could also think about it, is technically for this one being squared, there's a little radical right here of 2. And technically what's happening is, those 2 are kind of being divided out, or they're, you're kind of dividing that 3 by 2, and then whatever's left there is coming out here and being added. So technically, however you want to think about it, there's several different ways. I'm taking out the a square one time. So the a square is coming out, and I'm going to write this so maybe technically you can hear it. You can see, because I feel like that's confusing. We could write it like this, a, or we could simply write it out like this. This is 3. I'm going to take out this a square, and I'm going to leave this a. This a, so those 2 a's, these 2, or this a square, is going to come out as 1a. So for technically it comes out and it looks like this. Well, what would happen right here? Those 2 a's, the exponents would go ahead and add together. If I multiply those together, it becomes 12a squared. I know I'm really oversimplifying that, but I feel like a lot of you guys are really confused with this situation. So I wanted to break that down. So this term, or this right here, becomes 12a squared to the radical of just 3a. We basically took the squared out of that and the square of a and brought it and added it to this one. Going to this. We've got all kinds of issues going on here. If you look at it, and I'm going to write out what we're doing and then I'll erase it and show you what we got. The 32 needs to be broken down because I know that the 32 has this, it's got this perfect square in it there somewhere that I need to get out of it. And you can think of it however you want, but basically, if we were just factoring down the 32, you might think about it. If I'm taking the factor of 32, technically that would be 8 times 4 is 32, but fixed, and right there, there's a perfect square, but there's also another one right here. So you might want to go ahead and put that down as 16 times 2, or you might want to say, all right, I'm going to factor down everything. I've got 8 times 4, right? 8 times 4, but technically that's going to be 4 and 2, right? And I'm just going to put those 2 4s right there. So what's happening? These 2 2s are going to be coming out of there. So technically, I've got a 2 coming out of this one. There's a 2. I have another 2 coming from this one, right? And me multiplying all of those is going to become 16. So eventually my number that's coming out of that radical is going to be 16. Now we need to deal with these letters, okay? So we've done the numbers. Let's look at what's happening with the letter. I have A7. Well, technically, how many 2's do I have in there? How many A squares do I have in there? If you're completely confused, just write how many, there's 7 A's under there, right? 1, 2, 3, 4, 5, 6, and one more. And then what I'm taking is each one of those. There's 2 A's, there's 2 A's, there's 2 A's, or basically I'm taking out each one of those. I have 3 A's, 3 double A's, or 3 perfect squares of A's. And that will come out under here. And the only thing that's left under there is going to be the radical of A. So that's just showing you how we broke it down. What's going to actually be left after breaking all of that down? 16A cubed to the radical of just A. Let's go over here. So remember, searching for perfect squares. Searching for a perfect square. This one's going to be easier than the 2 we've dealt with. What would be 2 factors of 27? How about 9 and 3? Perfect square. Perfect square is going to come out. A is just going to hang out here with it. This perfect square is going to be 3. It's going to multiply to that A. So 3 times A is going to become 24. A square is going to stay there. This A, or this 3A rather, is going to stay under there. We took out the 9 and multiplied. The 9 was a perfect square, so I took out the 3 and multiplied that to the 8 to get 24. What's still underneath the radical? I just keep it there, 3A. Last one. You should know that, hey, there's a perfect square hanging out here in 18, and there's a perfect square hanging out there in the A cubed. So we can look at it. I'm breaking it all down. That would be 9 times 2. That's a perfect square. And then if we you could break it down like, hey, there's an A square there. Or there's an A, and then there's another A. There's an A times A times A, however you want to look at it. That's going to come out. This 9 is going to come out and multiply to this 3. Let's multiply. And this A, these 2 A's, or this A square, is going to come out as another A. What's going to end up happening? I'm going to have a 21. This exponent, if I multiply this A to this A square, the exponents are going to add. It becomes A cubed. Let me get rid of everything else. We got rid of that. What's going to be left under here? We got rid of the A squared. What's left? 2A. So everything underneath the radical sign that's left is 2A. You probably think, I would love to take a break right now. I'm so done with simplifying all this stuff. But you need to go back over and remember what this entire chapter was about. It's about combining like radicals. Do I have any radicals that are left that are like? I've got the 3A. The 3A needs to be combined. So I have 3A, that was the 12A square on one, and I'm going to add the 12A square to the negative 24, to the negative 24A square. These A squares are not going to change. That's the other thing. We have to look at those to make sure they're like terms as well. They're like terms as well. So I can combine these because this A square is like term, the 3A under the radicals are like term. So this is going to become, if I put the positive 12A and add it to the negative 24, I am going to subtract, take the sign of the larger absolute value number, that's going to become a negative 12A squared to the radical of 3, and then I just bring my other 2 down, which is the 16A cubed to the radical of A. And then I have another one over here, which is, wait, do I have another one? That's the 21A squared. Oh, now I see. I left out a 2. There was another 2 there. That's my issue. Somewhere over here I left out the radical. That's right, because this was technically, there was a 2 under here. These 2 can combine as well. So I have a negative 16, a negative 21 added to the positive 16. They would subtract. That would be a negative 5. They're both A cubed to a 2A. Sorry guys, just completely overlooked that. So this is your answer for another quiz thing. Now since I'm going over them and breaking them down step by step, I expect you to show some work, not just write an answer down. Okay, so that has gotten through. You should be able to finish part of 11.5 quiz now. If you have any questions, please feel free to call, leave me a comment. Have a good day, and hopefully we'll see you later.